Hello and welcome everyone, and thank you for joining our live webinar. My name is Kyle Paghetti. I'm a Senior Campaign Manager at Hach, and I'll be your host for our session. Today we'll hear from Hach experts Vadim Malkov and Terry Smith and learn about how accurate chlorine monitoring is essential for regulatory compliance and process control in municipal and industrial applications. Before we begin, here are a few helpful tips with our Q&A session. We'll be holding a Q&A session right after the presentation. If we cannot answer all questions live, we'll follow up with you directly after the event. If you experience any technical issues during the webinar, you can use the question box to reach out to me. However, please try refreshing your browser first, as that resolves most common problems. If you would like to continue the conversation about today's topic with one of our account representatives, simply click the Contact Us button and we will have your sales representative reach out to you directly. Live support will also be available throughout the webinar. Feel free to use the live chat for general questions. If you meet the requirements for participating, certificates will be sent to you after the presentation. Finally, today's session will be available on demand, and we will send you an email with the link shortly after we conclude. And at any point during or after our webinar, we encourage you to take our survey and share your feedback. Now, I would like to introduce our presenters for today. Dr. Vadim Malkov is a Principal Application Specialist at Hach, specializing in drinking water and disinfection. Since joining the industry in 2002, he has led municipal and industrial water quality studies and contributed to the development of several process analyzers and applications. Vadim has published and presented widely, and his involvement with the AWWA and the IWA makes him a trusted expert in the water community. Terry Smith is a Sales Development Manager with over 41 years at Hach and holds degrees in chemistry and biology, an expert in water and wastewater analysis. He has trained thousands through Hach's technical courses and brings deep knowledge of instrumentation, process control, and compliance. With additional teaching and communication training from Texas A&M, Terry is a highly effective educator and trusted industry resource. Before we dive in, just a quick note that today's session is meant to be educational. Our goal is to share helpful insights and not endorse any specific technologies or process. You're welcome to share this information internally as long as Hach is credited as the source. Who is Hach? Hach has been driving water analysis innovation since 1933 with more than 50 years of expertise in chlorine monitoring. We help municipal and industrial customers worldwide achieve accurate, reliable disinfection control through proven technologies and trusted instrumentation. We do have global reach in both manufacturing and engineering, and we also have direct sales, service, and distribution networks you can leverage for any support needed. We're here for you, and you can assist you with all of your water needs. We have a lot to cover today. We'll start with a comparison of chlorine monitoring technology, reviewing the pros, cons, and key selection criteria for colorimetric and amperometric options. Then we'll take a deep dive into the CL17SC process chlorine colorimetric analyzer, exploring its features, benefits, and real-world applications, along with best practices for installation, maintenance, and troubleshooting to keep your process running smoothly before wrapping up with a Q&A. Terry, I will hand it over to you to kick us off.
Thank you, Kyle. We're going to discuss water disinfection methods, regulatory aspects, so that we can see what fits your application. As you can see from this list, there are a huge number of disinfectants used in the industry in water and wastewater. But what we're going to really talk about today is going to be chlorine. We talk about chlorine because it's the main disinfectant for drinking water, and it's strong, it's inexpensive, which is why most drinking water systems use it. It does have a negative and high disinfectant byproducts potential and some safety and security issues. And it does carry a distribution residual that helps prevent problems in the distribution system. The one thing that you probably don't know is that chlorine and filtration are probably the biggest improvement in public health in the last millennium, as far as preventing disease and keeping us from having people sick and dying. Safe Drinking Water Act is the regulations that EPA uses, the National Primary Drinking Water Standards, National Secondary Drinking Water Standards, and U.S. EPA approves methods for drinking water quality monitoring. The ASTM methods, standard methods, and EPA alternative methods are what are used to be able to report those answers. Maximum required chlorine in residual at the point of entry is 4.0 milligram per liter. That's actually an annual running average, so maybe a little higher in the summer and a little lower in the winter. The minimum is 0.2 milligram per liter at point of entry. In distribution systems, it varies with states. Some require 0.1 to 0.2 milligram per liter. Other states still require just a detectable amount. Amperometric and DPD colorimetric methods are what we use to monitor continuously. Both are sufficiently accurate. The standard method is 4,500 CLG versus the EPA method 334.0. And there's an IDC required. What does that mean? We will go into that. With standard methods 4,500 CLG, DPD colorimetric online or manual grab samples are approved for chlorine monitoring. It's considered the gold standard, chlorine residual determination. And its flexibility on calibration frequency is very basically as needed. EPA method 334, online amperometric continuous chlorine analyzer. It analyzes continuous flow versus a batch. It does work well as long as the water is stable for pH, temperature, and TOC, but it requires an initial demonstration of capability. That means calibration verification with DPD colorimetric method prior to approval for compliance monitoring. And this IDC is a little more complicated. It can take up to 14 days for you to complete. Let's review chlorine chemistry a little bit. What are we talking about? Free chlorine is when we dissolve chlorine gas in water and we end up with HOCl plus OCl minus, hypochlorous acid plus hypochlorite ion. This is a strong disinfectant. It does a great job of killing bacteria and viruses that are detrimental to human health. Combined chlorine or chloramines, or sometimes we make them on purpose where we're making monochloramine for surface water systems. And then we can also have issues where we're not putting in the right amount of chlorine and ammonia and get dichloramines or trichloramines. And then we also have organic chloramines, which have no disinfecting value at all. So dichloramines and trichloramines are a major source of taste and odor. As I always say, the dichloramines taste bad and the trichloramines stink. And we also have less disinfecting value power going from free chlorine down to chlororganics, which have no disinfecting power. But all of this is considered total chlorine. So if I do a total chlorine test, any or all of these present will show up on that test. We also have pH influence on free chlorine, monochloramine, and dichloramine. The pH determines what we have. So it's very important that we know the pH and pH be stable. So if we're looking at disinfectant testing methods, you've got the colorimetric where you've got field and laboratory, as well as the online. Amperometric, you have an amperometric titration, and then you have an online amperometric probe. Those are not the same. So, analytical technologies. With amperometric, we're looking at millivolts, milliamps, output proportional to the chlorine concentration. They are continuous. You get a fast response to chlorine changes, and it's reagentless. Major deficiency, it's online only. It's calibration dependent. Matrix influences, we can go into a little bit later, and then it also has a sleeping effect. With colorimetry, we're measuring a change in color intensity proportional to the chlorine concentration. It's direct and accurate, stable calibration, independent of sample conditions. You've got lab and online with the same method, but it is non-continuous and it does require reagents. So let's look at online instrument selection guide. Here's your thought process. Look at the major performance specifications, technology key differentiators, research the detailed instrument specs. See what's most important to you. The treatment process realities, keys to the application success, or what your process is really like. So, first, does the instrument range cover your expected values? Chlorine concentration, 0 to 10 for colorimetric, 0 to 20 for amperometric. Does the pH range fit your application? Well, with colorimetric, pH is not an issue. With amperometric, pH needs to be between 4 and 9 for the probe to work properly. Number 2, what is preferred for your situation? So we can look at influence of sample pH, chlorine concentration, temperature, flow, and/or pressure changes. We'll get no impact on the colorimetric. Readings on amperometric can be impacted greatly, and recalibration may be needed on a regular basis. Calibration generally is not needed on colorimetric, and calibration is required frequently on amperometric, at least once a week. So, average routine maintenance. With colorimetric, we're going to replace tubing every 6 months. With amperometric, we're going to have to replace the membrane and electrolyte and/or electrolyte every 3 to 6 months. That will cause you to have up to 8 to 12 hours of uncalibrated readings. It takes a while for the new probe, new membrane, to repolarize and get ready to go, stabilize, so that we can actually do the calibration. With reagents, on the colorimetric, we have to change reagents every 30 days. You don't have to do that on the amperometric, but you will be calibrating at least every week. Reagents in the discharge, you have that on the colorimetric, and you don't on the amperometric, although both still have chlorine that you have to deal with. Multi-parameter. The colorimetric is a single parameter, whereas amperometric can have a pH and temperature probe added. So, what specs are more suitable for your application? On the limited detection, both have a 30 part per billion limited detection. The accuracy on DPD below on the 5 parts per million or less is plus or minus 5% or 0.04 milligram per liter, whichever is greater. The CLF10 is plus or minus 3% below 7.2 and plus or minus 10% below 8.5. And the CL10 has that same plus or minus 10% below pH 8.5. You also have to have stable pH units, plus or minus 5, to be able to get good response. Response time, the batch process is 150 seconds cycle time. Continuous analysis for the CLF10, but we do not get a full response, or 90T, or T90, 90% of the total response takes 140 seconds. Whereas the CLT10, 90% of the total response takes 100 seconds. So there's really not a great deal of difference between those. On regulatory method, the standard method 4500 CLG, the 40 CFR 141.74, or the EPA method 334 are usable on the colorimetric method. On amperometric, EPA method 334.0 is the only method. Automatic cleaning is not available on the colorimetric. It is available on the amperometric for an optional cost. Okay. Can your utility meet the requirements? Can I replace the reagents monthly colorimetric and manage the waste stream if required? On amperometric, I need to be able to have an uninterrupted sample flow, uninterrupted power, stable sample pH, stable chlorine. All those need to be that way because the amperometric probe requires it. So we go through and we compare the basic specifications. We evaluate technology key differentiators, consider detailed instrument specifications, and keys to successful application. The whole idea, we go through this summary. Here's what we look at. Colorimetric is accurate without calibration, independent of changes in sample pH, chlorine, concentration, temperature, flow, and pressure. It is not reagentless, and it is not continuous. Amperometric is continuous measurement, fast response to changes in chlorine concentration, and it is reagents, no reagents in the waste stream. It is not independent of changes in sample pH, chlorine concentration, temperature, flow, and pressure. And it is not accurate without calibration. It must be calibrated at least weekly. So, main takeaway, reagentless is not maintenanceless. The method matters, application matters. So next we will go to online chlorine monitoring with the Hach CL17SC colorimetric chlorine analyzer with Vadim. Thank you, Vadim.
Thank you, Terry. Hello, everybody. Let's dive deeper into Hach instrumentation and particularly the colorimetric chlorine analyzer. And before we go there, this slide depicts the Hach flagship process chlorine analyzers. You see on the left-hand side, the amperometric analyzer, which reflects all the benefits Terry just highlighted in the previous section. It's reagentless, it responds fast to the chlorine concentration changes, and it measures free or total chlorine with the different sensors. On the right-hand side, there is a colorimetric analyzer, which provides accuracy all the time. It doesn't need the calibration. So you can always have a choice between the fast response of amperometric and uncompromised accuracy of colorimetric. The, colorimetric chlorine analyzers family at Hach, they have CL17SC and the ULR, ultra low range version of CL17SC. They both can measure free or total chlorine reagent, CL17SC can measure free or total chlorine residual with the reagents, with the different reagents, while the ULR version is designed only for total chlorine, and there is a reason for that. We'll talk about this later. The main differentiating feature of the ULR version is the very, very low limit of detection of 8 ppb. All right, now the connecting link between the analyzers here depicted on this slide is the SC controller. Both sensors, like many Hach sensors, are SC family sensors. So they require that controller, a common controller, which provides a lot of different features, communication features, internal and external. We'll talk about this in the next few slides. Let's focus on the main differentiating features of the CL17SC analyzers and benefits they provide. Well, first of all, it's the visual management, or aids. The measurement light cycle lights inside the analyzer show where analyzer is now, what is it doing exactly. The 3-color status light is visible from far away and tells the operator immediately the analyzer is doing good with the green light, or it requires some attention with the yellow, or it's not working and requires immediate attention with the amber or red light. The built-in flow meter provides real-time flow readings. However, it has other functions such as automatic standby and automatic restart of the analyzer. So There are multiple features and functions, even though built-in flow meter is an optional device. Colorimeter window provides another visual aid to see what colorimeter is doing right now, whether stir bar is in place, what is it doing, is the color being developed, so it's going to be easy to watch if the reagents are delivered, color is developed visually. In some situations, when there is a direct sunlight, which is absolutely not recommended for the installation, this window should be taped. Now, tubing harness, that's the biggest, part of consternation with the previous legacy CL17 analyzer. Now it's improved enormously. We created a tubing harness, which is pre-assembled and can replace all the tubing along with reagents in a matter of minutes. So expanded management range, it's all, comparing to the legacy machine, it's double the range. And the on-screen diagnostic menus represented or presented on the SC controller. Now they provide quick identification of warnings, errors, provide variety of communication options. We're going to dive deeper into some of those features, such as particularly addressing routine maintenance. Those features provide much easier routine maintenance. So the redesigned tubing and pump system, the new one-piece tubing harness, as was depicted on the previous slide, and you can see it here as well on this slide, and also step-by-step on-screen instruction. You can see here the example of cleaning function, how to clean the analyzer. The instructions are very simple, step-by-step, so any new or even experienced user can benefit from these features with a high confidence. Now, the controller. This controller provides also smart version with a connectivity to the cloud. However, the internal functions such as diagnostics, improved menus, data capture and logging features provide additional capabilities. And the communication capabilities externally and internally improve efficiency and save a lot of time and money. We have multiple communication options, the protocols to connect the instruments, the sensors to the outside devices such as SCADA or DCS systems, and that is provided all by the SC controller, and SC4500 is represented here as the latest representative of the SC family of controllers, Hach. Now let's talk about more of a specifics on the CL17 SC. You can see here on the right-hand side of the slide, the measurement range, the accuracy, and the measurement interval. The measurement interval stays the same as it was with the previous legacy machine, the CL17, which industry knows very well. Now, let's talk a little bit about the sample flow. The new machine was designed for clean drinking water applications. It is more sensitive to the sample flow than the previous analyzer. However, even the legacy machine may have a problem with too much of a flow to the analyzer. We've seen it all here and there. Now, the required sample flow rate for the new analyzer is between 60 and 200 mils per minute. It's a little less than it was allowed by the old machine. And the ideal performance is achieved at 120 to 200 mils per minute. So the internal flow meter will display that number, and you will always see what is the flow rate through the analyzer when it's flushing the system. Now, back to the applications. As I said, this analyzer was designed for clean drinking water applications, being major target or major application pool for this machine. The other applications, it can be used, absolutely, in other applications. However, they may require additional sample conditioning for correct operation. Maybe additional filtration, and we'll talk about this in the next few slides. But at this point, let's focus on the essential applications for the CL17 SC analyzers. Target applications, clean water, as I mentioned. So those are represented by drinking water post-filter. The post-chlorination, you can see here on the right-hand side, the applications or the measurement points depicted by the arrows, encircled arrows. They show the target applications where the instrument will perform absolutely perfectly well when all the conditions for sample, flow and pressure are met. Now let's talk about pre-chlorination. On the left-hand side, you can see the pre-chlorination, when the instrument can be used right there before adding the coagulant to measure the concentration, residual concentration of the chlorine injected in the raw water, or can be used also in the middle of the process after the clarifier, settled water, measuring the chlorine residual going into the filters. In many situations, it is necessary when the process requires that, treatment process requires that. Now, those applications depicted by the stars, they may require more frequent cleaning of the Weiss strainer and the flow meter, depending on the sample conditions. Moving on to the other applications, such as dirty water applications. And first example, of course, is the wastewater. And first of all, is the municipal wastewater. So the instrument can and should be used in the effluent, and particularly the tertiary effluent, which is a normally filtered wastewater, is one of the possible and very reliable applications for the CL17SC. Now we have other applications with the dirtier water, such as pre-disinfection chamber after the injection of chlorine, post-disinfection contact chamber to measure to provide the closed loop control, for example, for the chlorine feed. Those applications may require additional extra time and effort to clean the Weiss strainer and the flow meter. Now, we can talk a little more specifically about application number 4, the last one depicted on this slide, which is measuring the final effluent after dechlorination. And this is where the chlorine concentration is extremely low, and therefore the instrument may suffer from the biofouling. And it's very common issue with the dechlorination applications. And yes, we have some solutions for that. And most importantly, for this application to ensure the concentration of chlorine is below the discharge limit or the permit level, the ULR version of CL17SC can be used. All right, let's dive deeper into this pool of dirty water applications. And this is a nasty application, very dirty water, because the cooling tower is exposed to the elements, and the water in the return cycle can be very nasty, very dirty. So this application will require additional filtration and more frequent cleaning of the strainer, filters, sometimes flow meter, and the flow cell. So here are the options. Either Hach we offer those options, or there are off-the-shelf available options for this filtration. What is common about these options? It's a 100 micron filtration, which usually sits after the 40 mesh strainer. The high capacity of this strainer or filter is absolutely advised here. And you can see those options available through Grainger or even Home Depot sometimes. In the middle, you can see the Hach filter. Hach offers this filter for other applications and other instruments. And this filter is very suitable for dirty water applications with the CL17SC, especially if you apply the disc filter element, which also provided by Hach or sold by Hach. And that disc filter has much higher capacity to filter out all those impurities. And it's much easier to clean and easy to replace. If you have a spare filter, it takes literally before 5 minutes. I tested it myself to swap the filter and let it work for another week. The ultra pure water applications, they require some special note and special attention here, because the water normally is dechlorinated in those applications. And if it's dechlorinated, once again, the main instrument to use is ULR version of CL17. What is very common and important about the dechlorinated water? It's biofouling. It's the main source of extra maintenance, which is a cleaning of the instrument itself, the measurement cell, the flow meter, if it's connected, because flow meter can be bypassed. As I mentioned, it's an optional device. Now, why ULR version? Well, because the prolonged exposure of RO membranes or nanofiltration membranes to chlorine exceeding 38 ppb, it may be very detrimental to their structure and integrity. Therefore, accurately measuring chlorine below that level, 38 ppb, is crucial because the operations, the treatment professionals, they need to maintain that very delicate balance between having some chlorine to keep the biofouling at bay from the growth, uncontrolled growth, and having low enough to not damage the membranes. All right, from this slide, we're gonna jump to the installation. And I mentioned that this instrument, the CL17SC, may be more sensitive to the flow and pressure of the incoming sample. And this is how you really take care of it. You need to use, of course, the analyzer in the intended applications. Yes, that's when it will demonstrate the best performance and meet the expectations. Correct sample conditioning kit should be chosen. And the standpipe, if it's chosen, must be mounted as required. Now, if you look at those three options on the left-hand side, of course, differentiation with the pressure. Pressure regulator is a good option when there is a gravity feed with above 5 psi, the Y strainer. Regular standpipe is a good option for gravity feed and lower psi. Why I'm saying gravity feed? Because this is non-pulsing sample delivery. If you have a pump, then some pumps, they provide pulsing pressure and create inside the analyzer sometimes a water hammer. And that is very detrimental because it can blow off the tubing and flood the analyzer. We don't want that. So in those situations, the modified standpipe kit, which provides different flow path, it can be used at above 10 psi and with the pumps providing pulsing pressure. So those things need to be absolutely taken into account, and then the instrument will perform perfectly fine, and the maintenance will be confined only in this routine schedule, which calls for cleaning the cell. Conservatively, it's monthly. In the target application, maybe less frequently. Replacing the bottles, the reagents, it's monthly period. Now, yeah, it can be combined with the cleaning the cell. Yeah, why not? Because it takes an additional 5 minutes. Now, since the replacement of the bottles is also very easy, cleaning the Y strainer and the filter element in the Y strainer, on average recommended 6 months for the target applications. Of course, it can be and will be more frequent for dirty water applications. And that's why we recommend to adding filtration to minimize the maintenance requirements, the maintenance efforts. Now, store bar replacement and tubing takes about 2 minutes, and for target applications, it's every 6 months. It may vary, it may be 3 months when the conditions are not ideal, and cleaning the flow meter as necessary. And as I mentioned, cleaning the flow meter, we have documents outlining the guides, outlining the functions, the steps, everything, and it can be bypassed if it creates that type of nuisance. However, with bypassing the flow meter, as I mentioned, you may lose valuable functions of this device. Now, when everything is done right and something goes wrong anyway, there are 2 levels of alerts presented on the SC controller screen. The errors and the warnings, those are different by the color. And you can see very clearly from far away that errors in the red light, the screen is going to be red. What is important about this, what important to remember about red light, it's an error message and it's an alarm, and the instrument is not operating. It's waiting for immediate attention. The yellow light gives a warning or supplements the warning. And warning means the instrument is operating, but it requires some attention as soon as practical. Now, of course, the messages here in this bubbles, they provide pretty simple warning what is wrong. Now we provide explanation on what to do, and more details may be found in the user manual. And the user manual, the latest edition, is available on the Hach website, and the handouts, which are going to be available for the audience, for the listeners, will have those live links. And every slide where there is a reference, there's a live link to the document. With this, I'm going to thank you very much for attention and hand it back to Kyle.
Yeah, thank you, Vadim and Terry, for an amazing presentation. Before we open up to live Q&A, we want you to know we're here for you. You could reach out to us via the contact window or visit hach.com for more information. Also listed on this page are some of our current promotions. For the full list, please visit hach.com/promotions. Here are a couple that are related to the topics that were covered today. We did have a lot of questions come in today, and if you have not submitted your question yet, please do so now through the chat. Some of the questions that we did have come in is the first one, in CL17SC, when would you have to clean the flow meter and how to clean or bypass it right?
I'll take that question. So yes, the flow meter is an optional device. It provides additional functions other than just displaying the flow. And cleaning it may be necessary when there is a particulate matter coming through or when there is a biogrowth. So those conditions will be easily reflected on the screen. When the instrument tells you low flow or not enough flow, you check the filter, you check the flow. If there is enough flow, that means the flow meter is clogged. The instruction is available on the website. It's step-by-step instruction. There is a cleaning solution which is injected using a syringe, and it works perfectly fine. This is how you do this, and this is how you do this right. Also, this guide includes the section on how to bypass the flow meter.
Great, thank you. Another one that just came in is which analyzer to use when chlorine concentration is 200 ppm?
Well, I can take that one. Nobody has, say, colorimetric option for this high chlorine concentration. Amperometric options available. However, it's, as Terry said, and we said in this presentation, the calibration will be an issue. So this application is very difficult. It's like a stormwater application with a blast of chlorine, and we are aware of these applications. There are amperometric systems measuring up to 200. However, the calibration must be done with the colorimetric method anyway. And the only way to do this right is to dilute the sample. And yes, there are some like post-market solutions for the automatic diluters. So this is what you can use. If you use an automatic diluter for your sample, then you can use any analyzer when it fits into that range. So that back to the selection guide, you need to understand the range requirements. And then if you use a off-market or aftermarket diluter, it will work as you set it up to work.
Okay, next question is, how do you clean the flow meter?
As I mentioned before, there is an instruction guide available on the website, but in a very brief, you have a cleaning solution, you disconnect the tubing, you connect the tubing with a syringe or syringe to the tubing and inject this into the flow meter. That's all you can do. You can do this a couple times, then flush it with dry water, and the flow meter is clean. I did see another question about measuring with the CL17 total chlorine only or free chlorine. Yeah, I will repeat it very clearly. The CL17SC can measure either free chlorine with the reagents for free chlorine, the appropriate reagents, or total chlorine with the reagents for total chlorine. The ULR version was designed only for total chlorine because this is what is necessary to A, address the dechlorinated water discharge, and B, to capture all the species which may affect the membrane in the dechlorinated water.
Okay. Next question, EPA 334.0. When did this become a way to use the amperometric analyzers to report?
I can answer that question. Yes, I was a part of the team working with the EPA on adopting that method. And it was first published in September of 2009 and promulgated into the federal regulations in November of 2009.
Next question is, could you change the sample rate for the CL17SC if needed?
Of course you can. With the valves included in the sample conditioning kit, you can adjust the flow rate as necessary, and you can absolutely maintain it within the ideal range of 120 to 200 mils per minute. Once again, you need to use the sample conditioning kit provided with the instrument. It's included, it doesn't cost extra. You need just to choose the right based on your sample conditions, whether it's a gravity feed, what's the PSI, what's the flow rate, and whether there's a pump.
Next question is, what is the pH range for mono, DI, and trichloramines?
That's a great question, and I know Terry can answer that question. I'll kick it off. So the ideal range to maintain monachloramine as the target disinfectant is above 8, which is like 8.2, sometimes up to between 8 and 8.5. This is the ideal range to maintain stable concentration of monachloramine. If the pH goes lower, below 8, then the equilibrium changes toward the dichloramine, and you have your taste and odor issues. Terry, you can add.
Exactly right. If we're above 8.3, we're going to have only monochloramine formed specifically. As you go below that, then you start seeing the dichloramines form, especially if there's not enough ammonia to react with the chlorine. That's the critical factor, is you need to have enough ammonia to react with each chlorine. Chlorine likes ammonia best. That's why we use it to help keep disinfectant byproducts from building up.
Thank you. And maybe the next webinar we're going to have is the chloramination practices, because we have great expertise with instrumentation, with the right instrumentation to make it correct.
Okay. Next question is, what level of turbidity would interfere with the ultra low range? At what point would you need the pre-filter?
That's a great question. And we're probably talking CL17 family of analyzers here. And it's either ultra low range or this regular. The turbidity up to 30 NTU, there is no issue. Above 30 NTU, there may be some masking of chlorine. So up to 30 NTU, it all should be fine.
Okay.
I can see that question from Mike Jimenez. He meant to ask about not the sample flow rate, but the cycle time. And no, cycle time is fixed at 150 seconds, and there are multiple reasons for that. Yeah, because reagents, it's a reagent dependent as well. There are multiple factors. So we decided a long time ago to fix the cycle time at 150 seconds to maintain the accuracy uncompromised.
Okay. Next question is, elaborate on the chloramines organics. How do you measure them?
That's a very, very difficult analysis if you try to measure organic chloramines. However, they can be deduced based on the analysis, total and free chlorine analysis. That's the simplest way to evaluate potential formation of organic chloramines. However, you need to know not just total and free, you need to know also monochloramine. And still, there are going to be some influence. There may be dichloramine included into this evaluation, but the three analysis, free chlorine, total chlorine, and monochloramine, should give you an estimate how much of organic chloramines you may have in your water. Yes, you probably need to also measure ammonia, free ammonia. So 4
Yes.
analysis simultaneously for the same sample, free and total chlorine, monochloramine, and free ammonia would give you a good idea of how much of organic chloramines you may have in your water.
Okay, next question. For very low chlorine concentrations, 0.05 ppm, which technique is recommended? The current application is to protect RO membranes downstream.
ULR CL17 or ultra low range version of CL17. That's very simple. That's the best instrument so far with the 8 ppb of limit of detection, which gives you anything above roughly 25 ppb accurate. It gives you accuracy. So for example, you have 30 ppb or 0.03 ppm with plus or minus 8 ppb. This is your measure below 0.05 with the accuracy of plus or minus 8 ppb.
Okay, thank you. Next question. If there is error in the header pipe, does long standpipe adequate for accurate chlorine reading with CL17 SC?
As long as the sample conditioning kit provides flow, enough flow to the analyzer, that should be all fine.
Okay. Next question is, what effect does high flow rate have on chlorine readings for DPD?
There should be no effect to the DPD reading as long as it's within our range on the analyzer. If we have higher pressure and we're flowing too much water through the analyzer, we can have some issues with that. But if we've got the flow rate correct, we're not going to have an issue. That's why we have a pressure regulator and standpipe to give us the proper pressure.
Thank you, Terry. That's exactly right. As long as you are within that range of 60 to 200, there is no difference. It's all about instrument mechanical performance and potential issues associated with the loss of flow or extra flow and pressure, mainly the pressure.
That's not the case with amperometric. With higher flow rate going past the membrane, your chlorine shows much higher, potentially twice as much chlorine as is actually there, because it's seeing more chlorine in a set amount of time.
Very
good
point.
Flow rate on amperometric is critical.
Very good point, Terry. Absolutely. Even for membrane-less, the bare electrode systems, flow is a critical factor. You need to maintain flow in a specific limits.
All right, thank you. Next question is, how well does the amperometric unit work on chlorinated well water that has not gone through a normal potable water filtration plant with variable well water composition as well cycle on and off?
That depends. It's one of the tough applications. I envision what you're talking about. So first of all, if you look at that selection guide, the last slide was on can your utility provide uninterrupted flow? Because interrupted flow will affect performance of amperometric. pH is likely stable. It's a groundwater. Chlorine concentration jumping around, it's not a good for accuracy. It will show you the number, but not necessarily the number will be correct. So all those factors are depicted specifically or gathered specifically into the guide, which is available and will be available in the handouts of this presentation. So you can always refer to this guide and meticulously walk through this and figure out what you really need for your application, because application matters. Absolutely.
One thing, if the flow rate is if you're able to have a constant flow by having a tank provide water when the well is not pumping, so you have a second source or a continual source of water, then the amperometric probe works fine, but it has to have continuous flow or else you're going to have problems.
Yeah, I can see that question from Chad Crawford here. Yeah, for small systems, it's not an option. However, we know that some amperometric systems, they work on skids, which are designed exactly for small systems. And there is a way to, figure this out. However, as Terry said, you need a backup water to run it continuously, like a loop through the system to maintain it wet, to maintain it with chlorine present in there, because otherwise the sensor may fall asleep. And there is a potential issue. It is a technology trait or technology deficiency. It's not necessarily specific to a brand. Yes, there are some sensors they may do better, some sensors may do worse, but it's a general technology trait.
Thank you. Next question is, what percentage of accuracy between CL17 and the SL1000?
Okay. When you compare two instruments, any two instruments, the rule of thumb is that you combine the accuracy specs from each instrument, summarize that, and this is your window where the difference should be. Usually it's 10%. If we're talking some ranges above like 1 ppm or so. Otherwise, it's a sum of limits of detection. So for example, CL17 has 30 ppb limit of detection or 0.03 ppm. SL1000, the PPA method, for free chlorine, it has 40 ppb, 0.04. So the sum of it is 0.07. So if your difference is 0.2 and 0.25, it's within 0.07. So you apply whichever is greater, either sum of LODs or the sum of the accuracies in percentage. Whichever is greater, you apply that number. This is the rule of thumb and the normal standard approach to evaluate the difference between the two analyzers, any two analyzers, as a matter of fact.
Thank you, Vadim. Next question is, could the ULR CL17SC control a PID loop for bisulfate dechlorination for RO feed water?
The answer is absolutely yes. The best way, of course, you use the controller, the SC4500 controller, which has the relay outputs or the PID loop control outputs. However, I know from the field the best practice is actually use a PLC.
Next question is that, sorry, someone's answering that one. Next question is, can you explain a little more how to calculate organic chloramine based on free, total, and monochloramine?
I tried to explain that based on the schematic or basic chlorine reactions that Terry presented in the slide. You see that there is a potential in the total chlorine, there's potential of presence of free chlorine species, the chloramine species, and the organic chloramines. Total chlorine will pick up everything. Monochloramine is a specific method. Free chlorine is not as specific. It experiences interference from the chloramines, not from organic, but from the inorganic chloramines. So therefore, it's just an estimate. Also, you need to make sure that there is either no free ammonia or neglected free ammonia in your sample to be able to derive approximation for the organic chloramines. I hope it makes sense. It's a simple math, but you need those for analysis. And it can be easily done with the SL1000 with the 4 chem keys, total chlorine, free chlorine, monochloramine, and free ammonia. You dip it in that, sample cup, and it gives you this result for 4. Then you do the math and derive what is likely your organic chloramines content there.
Thank you. Next question, how do you collect and manage the waste sample reagent after the analysis?
That's a great question. And since Hach is not certified for water treatment, we normally do not provide any advice on treating the waste stream because it's up to the regulators. And we always advise, ask your DEP, ask your regulator, because what we did, we analyzed the discharge of CL17. I did it with the external labs, and we found no regulated compounds in the discharge. That's all I can tell you. We have a letter, a formal Hach letter, confirming the results of that analysis. You can use that letter as you see fit with the conversations with your regulators.
The other key to that is that chlorine is regulated, as in going onto the ground, going into a stream. Whatever you're doing with the chlorinated water is going to be whatever your regulators require. I know if they're flushing water mains, a lot of times they'll have to dechlorinate the water if it's got the potential to go into a stream. So I would say you check with your regulators and see what they require and what they want, and go from that. Everyone is different.
Yeah. Next question. Can you have an idea of THM with free and combined chlorine?
Terry, if you can take that question, that'd be...
Okay, trihalomethanes are going to be multiple compounds. If you're doing free and total chlorine, I mean, obviously that could show up as a chlorine compound, but it's going to be so insignificant as compared to the chlorine compounds that are available. You're talking parts per billion versus parts per million. So there's no good way to say, well, if my chlorine is this, I probably have this much for trihalomethanes. There's no easy way to do that. Obviously, the higher the chlorine you have, the higher the organics you have, the higher potential for trihalomethanes you have.
Thanks, Terry. Next question. Can we calibrate the new model CL17S like the old model? Gain adjustment.
The answer is yes, you can, but the question should be slightly different. Should we calibrate? And then the answer would be no, you should not. And let's make sure that the calibration and verification is understood well. When you run a sample of known chlorine concentration through the analyzer and see the number which fits the difference, as I explained, the difference between the two values within 10%, let's, for simplicity's sake, you do not want to change the coefficients. You do not want to change gain or offset on the analyzer. You do not. Because if you change it, who knows, next time your chlorine concentration changes, it's lower. And then the gains you inserted, they're gonna provide the wrong answer. We've seen it in the field. I work personally with several utilities explaining this, and they changed their SOPs and stopped adjusting the analyzer when the difference between the two instruments, the reference instrument and the analyzer, was within appropriate discrepancy. Let's put it this way, statistically appropriate discrepancy. So that's the answer. But yeah, you can of course adjust those coefficients, not necessarily directly, but yes, you can.
I always say if I've got hundreds of data points, hundreds and hundreds of data points developing the curve that's in that CL17 versus changing it with one data point, just doesn't seem to be a good choice.
Thank you. And for the last question today, is it smarter to always use the Hach filter and disc filter where raw, dirty water is concerned to prevent biofueling? Is it okay to not include them in these applications?
If I've got raw, dirty water, we need a filter ahead of it. I don't care if it's ours, or I don't care if it's anybody else's that you like. The water needs to be filtered. Remember, we need to be below 30 NTU for the chlorine analyzer to work properly. And we also need to try and take out the large pieces that can end up plugging tubing and plugging flow meters and causing other maintenance issues. The whole idea of the filter is to prevent maintenance, prevent problems, and prevent having downtime.
Thank you, Terry. And it's not necessarily about preventing biofouling, it's preventing the particulate fouling. Biofouling is coming from a different, side. It's coming from the absence of chlorine or lack of chlorine. That's where biofouling is coming from.
All right. Well, thank you, Terry and Vadim, for answering all the questions. That's going to be all the time we have for now. If we did not get to your question, don't worry. We will have our presenters follow up. We will send out an email with a recorded link from today's session, and I would like to thank Vadim and Terry for being here and you, the audience, for the engagement. Please remember to take the post-webinar survey with the chance to contact your Hach representative if you have any further questions. Thank you and have a wonderful rest of your day.